morning, everybody. People are joining. We're going to give it another minute. Okay, we're going to get started. People join in. They'll join in. So good morning, everybody. I'm Paul Shmotoloka, CEO of NUE US Energy, former US Army veteran, and been working with drone warfare and counter drone warfare for a little over 3 years now, mainly in Ukraine, but also now working with various parts of the U.S. military. I'd like to introduce John Weber, our VP of Sales, who's going to be presenting today. I'll be a moderator. Very happy to have an open discussion, questions. We're very open to sharing all of our experiences. I would like to emphasize that we are very experienced in working daily with over 40 brigades in Ukraine. It's a unique conflict, but one that sets the tone for all future conflicts. And so we are very glad you guys could join us today. John?
Thank you. Good morning, everyone, and welcome to our webinar. We'll be talking about the drone operations for our modern warfighter, as well as some of the lessons learned for power generation over in Ukraine, and some of our great solutions that we have to apply to those applications as well. So NUE US Energy's been producing equipment for about 4 years. A lot of that equipment was originally designed with disaster relief in mind. And of course, unfortunately, when the Russian-Ukrainian war started, that was a disaster unto itself. And so we started designing equipment that frontline troops as well as medical personnel could use and depend on during that war. Some of the things that we've iterated on is making sure that we're producing a quality product that is truly portable and can survive in the battlefield. Part of that is because we work directly with our contract manufacturer to design exactly what we need, and it's proven itself out time and time again. And a lot of it is because of the customers like yourselves have given us that feedback, and we've been happy to incorporate those ideas into it. And again, being able to build exactly what we need where we need it has been part of our plan from the beginning. We are based in Anacortes, Washington, which is up near the Canadian US border in the Seattle area, and down in Phoenix as well. We have over 500 units in Ukraine, from our forward operators all the way back to our medical guys who are providing relief to our the troops that are there. And as well with just disaster teams. We were at the LA fires. We were at Hurricane Helene. We've been working with NGOs to deploy. We've been working with disabled groups out of Florida, providing equipment when a hurricane or an extreme storm runs through, being able to provide that reliable power from something as simple as getting a wheelchair charged up all the way to making sure that if somebody has some serious medical needs like we've seen in Ukraine, that we can work and provide power for them as well. We've deployed with telecom customers, anything from a SCADA network and providing just a little bit of power so they can get their equipment deployed, all the way to providing a lot of batteries to telecom customers. Along the border, we've provided infrastructure. So instead of running a generator, needing to figure out all those logistics, which we'll touch on later on, we've been able to allow them bring that power exactly where they need it. They're out for a handful of hours. They come back and recharge our products from as little as 90 minutes up to 3 hours, depending on the size of the unit. Over in Africa, we have a lot of issues with power over there. I've been to Africa a handful of times in support for renewables, and they have rolling blackouts. They have scheduled blackouts, and for consulates in Africa. We've been able to provide that Starlink laptop, fridge, freezer, light sort of idea out there. And of course, with drone charging stations, this is something that has been asked for both in Ukraine as well as with our warfighters here in the US. And we're beta testing with the United States Naval Academy with the midshipmen providing this charging station, not only for their drone chargers, but for their airsoft batteries, because that's how they're practicing using their stuff. So we're sort of a universal charger within that system. And being able to provide power with MRO applications, anything from running a heat gun to pull adhesive off of the front of Humvees to being able to run welders, grinders, compressors. We can bring the power and silent power exactly to the vehicle rather than them having to shuffle vehicles around and things like that. One of the most important parts about and our differentiation between why can't I just use a generator in this is it is absolutely silent power. And that is a big difference when you're trying to run a disaster team. Where verbal communications, as well as just over the mic, or even in the film industry where we work, we see a lot of that application where they need silence or they appreciate that silence. You can see here on our screen, we've got our Kraken group here that have deployed frontline troops. Our drone charging there in the center, you can see with our deployable solar panels, it really only takes a couple of minutes to fold that up and get it going. Or if you walk those numbers backwards, you'll see that you can deploy that panel out very, very quickly and get power running for tools or whatever those needs are. We have quite a bit of equipment over in Ukraine for ambulances and the anti-drone applications there. On the right-hand side, you can see our sort of two flagship products. That's the 3651. So it's a 3.6 kW inverter with 5.1 kilowatt hours of storage. And then we have the little bit smaller unit. It weighs less than 70 pounds. So it's quite man portable for a single person. That is the 2425. So that's a 2.4 kW inverter with 2.5 kilowatt hours of storage. Deploying the right power and bringing it out exactly where you need it. Within a drone ecosystem, this is an electronic warfare jamming system. And what's really important to note here is that because AC power plus USB power is very universal in requirements, we're able to power laptops, charging stations, electronic warfare, antenna system, as well as just provide lighting within the vehicles itself so that they don't have to run that vehicle all the time. On the electronic warfare side, they're able to deploy out a small unit and be able to leave that behind if necessary to be able to provide jamming, and they can also detect when drones are coming over. Touched quite a bit on the medical already, but it is worth noting that we have become a reliable source of power within the medical, especially over in Ukraine. They can wheel those units around, and we've had babies being born through cesarean section where a transformer was knocked out by an attack, and we kept the lights on and the equipment running so that they could finish the operation and have a baby be born. So a bit of a feather in the cap there. And special operations, because we do build a very small portable unit like you see here, and we've actually iterated based on feedback. We have a new unit out called the 605, again, a small black Pelican case style unit that allows you to take this unit out into the field, weighs less than 20 pounds and can provide quite a bit of power out in the field for teams needing to charge drones and things like that. We will touch a little bit on system sizing and some calculations so you guys can learn to do some of your own calculations. But let's talk a little bit more about what's going on over in Ukraine. And I will have Paul sort of talk about this next slide. Paul is American Ukrainian, first generation, speaks Ukrainian, and so he's worked very closely with this teams. So Paul, if you'd like to share about these photos, I think there's a lot to talk about
just
here.
to give you guys some context and applications, the upper left, the guy with the shotgun, that's actually in Kursk Oblast, and they are connecting one of our units to a jamming and drone detection system. The two go hand in hand. You can't keep the jamming on at all times or else it gives a big signature. So you're detecting, then you're jamming after you've detected. To the right of that, that's actually inside an M113 armored personnel carrier. It's 70 years old, donated by the US, and we outfitted it and created a battalion tactical operating center. And that was after they had their main portable generator destroyed by drones. So the heat that the generator emitted created a target, and nobody was hurt, thankfully, because it was located away from this vehicle, but they just about had it with those generators, and they've moved it to battery power. In the bottom, to the right of that, frontline command and control, that's actually very often in Ukraine. They're located in houses, buildings, basements. So the ability to be able to use indoors is what is a big differentiator over gas generators. To the right of that, artillery and anti-aircraft missions. That's actually an M777 155 millimeter howitzer, very near and dear to me as an artilleryman. But what I want to point out is about 15 kilometers in front of them was a recon team about 300 yards or 300 meters from the Russians. They launched their drone, and they ran their Starlink powered by our portable power, and they were searching for counter battery fire or missions, and they were able to spot artillery. There's an actual mission, and actually found some forward observers that they took out. So they hopped the data from the drone to their Starlink, then hop it back up into the Starlink ecosystem. This battery, like I said, about 15 clicks behind, and they have their tablets, they see the video, and so does fire control at the battery level, and they have very quick authorization to fire as a result, and that's a very effective improvement in counter battery fire. To the left there with the big Ukrainian flag, that's in Kursk Oblast. That's the 80th Air Assault out of, and they were very engaged. Mainly drone team missions. Sadly, either this unit or one of our other units, we have about 15 with them, was actually captured as the groups were enveloped. So it is a real situation the guys are in, and they've got to be as stealthy as possible. Medical is, in frontline stabilization points is critical, and then of course some drone recon teams. But this is not the limit of the missions. There's just tons more happening all the time.
Yeah, Paul, we get photos from our teams over there almost on a daily basis about how they're using this product. And, when you have portable power, it's only really limited by your imagination on where you can deploy it. And they've been very, very creative, moving power exactly where they need it. And that's one of the great benefits of these units. We talk about drone ecosystems. You have your satellite communications, as Paul indicated, with the Starlink, with the M777 or M7 artillery, the 155. That unit really tells a great story about how it's getting used. We're not only being able to charge those batteries and get them up to full so that recon drones aren't dependent on generators, but instead can use our equipment. With directional antennas, typically when you get out over the horizon or you get out more than a couple of kilometers, you need to start actually not emitting in every direction, but actually having a directional antenna to not only listen to the drone, but send commands to those drones. And those require their own power source to be able to amplify and push that EM signal out to those drones. And so when we're talking about building out the ecosystem, every part of this is absolutely important. If you've ever watched any of the videos around drone command, there is a hierarchy and structure for giving okay for attacks. Is that the place that we want them? And so being able to communicate back with the Starlinks, being able to use radio communications and not depending on a thermal signature or an acoustic signature from a generator is absolutely important. As Paul spoke to already with the electronic warfare side of things, not only are they able to listen, but then be able to jam. And so with those jammers, that's actually quite a bit of power that gets put out when those jammers get turned on. Passive listening is a very low load. So you could potentially deploy out one of our units in the field, have just a listening station there and expect it to be out there for days at a time, even without solar or any other charging source. But then, when you start getting into the larger loads that occur when you start jamming, it's nice to have a big, robust battery there. Radios, it goes both directions for communications as well as control, and you got to see what you're doing. So those screens where the the commander plus the pilot are both seeing what's going on. The commander can provide sort of a wingman-like situational awareness to what's going on around the pilot, taking in a different set of information, giving the okay for an attack, and being able to charge those screens or power them directly along with the laptops. And then the goggles, they have their own requirements for being able to charge, plus the controllers themselves, and just sort of the basic requirements inside these sort of bunker basements, if you will, with lighting. And it was proven out very, very quickly at the beginning of the war that generators just weren't doing their job because they were getting blown up. And we'll talk a little about, you can see here, this is a 12,000 milliamp hour battery. We'll talk a little bit about sizing here shortly. For in the field training, we're seeing, because of that rapid deployment, there was an article recently, they were talking about building 1 million drones this year in 2025 in Ukraine. And so the requirements are astronomical for those drones. And as that technology iterates month over month, actually, being able to train the teams, being able to provide power to the laptops. You can see there on the left side that there's actually a Starlink. We're powering all of this equipment directly from the 2025 that you see here. So there's a lot of equipment out there, and we're providing not only forward operators, but when guys are coming back behind the lines, being able to get a hot meal can all be powered from this unit that you see here.
Yeah, so one of the things I want to highlight there is that there's just a lot of training that needs to take place. So the whole ecosystem sits within these training centers, and they're constantly cycling batteries. So the equivalent of this, I think, in the US is range work. There are a number of drone testing ranges and work being done. I was just at Fort Carson on Friday, and there's an Op 4 that is essentially training troops to understand how they get things dropped on their head now. And all those guys really need to recharge their batteries in the field, even though it's a testing environment.
Exactly. So electronic warfare is just as important as the ecosystem within the drones, because we have, this is a recon team. Again, this is about anti-idle. They don't need to run the vehicle to power the equipment. Instead, they've got their panel, they've got their NUE US Energy power there that's allowing them to listen and do recon to understand where the enemy is, pick up EM emissions and things like that. One of the saddest things that I learned about is, ambulances are now needing to be equipped with electronic warfare because of this thing called ambulance safari, where the Russians will toy with ambulances that are coming up to the front lines and moving troops from triage areas to hospitals are now being attacked. And so they're having to equip their ambulances with the electronic warfare to try to get the drones a better chance to survive with drones in the air. And this is an example here of a Russian drone that fell from the sky. And so, they've already disabled the battery off of it. You can see the open plug there, but it's both on the Russian side as well as the Ukrainian side. A little bit of duct tape and a shaped warhead is how things are going there. And so that electronic warfare, dropping those drones out of the sky, I've read that as high as 80% failure rate because electronic warfare is working on both sides. And thus the reason why they have such high production numbers on drones is because it's a difficult field. And so again, going back to that training, learning different ways, methodologies for how to bring your drones in, how to understand if your drone's within an electronic warfare bubble and being blocked, what do you do? And so this is an important part of the whole war there, is making sure that the operators understand how to get to their targets and not lose their drones due to EM emissions. One of the first things that was learned early in the war was there's lots of generators in Ukraine, and they didn't survive very long. The thermal signature, as well as the logistics of delivering fuel, created a huge exposure there. With the thermal signature, even with solar panels that you can see here, we'll touch on this a little bit more. Solar panels easily reflect sunlight, just like glass reflects infrared. Solar panels have glass inside of them or are reflective. And so it can be quite difficult to bring in a little tiny unit. Why does it have to be so big, John? Is because you actually need that amount of storage to be able to deploy and be able to use multiple charging to batteries, multiple mission sets with stored energy behind the enemy lines. It's great. This can do mission extension, can lower the logistics of delivering fuel. But when you get closer to the front lines within that 10 to 15-kilometer range, suddenly having a generator out there is a no-go. It exposes your troops to attack. It exposes the position. And so having silent portable power that you can bring downstairs doesn't create the thrum of a generator, doesn't create the thermal signature. This is a great way to be silent and bring the amount of power. Typically, what we're seeing with deployed equipment is that they will bring that equipment, it's an N+1 model, meaning that there's one deployed out on the front line and there's another one that's well behind front lines getting charged from a typical AC source. And then when they bring in the food and water, things like that, they bring a replacement, or if they're bringing out wounded, they can bring a unit out as well. So they're always swapping these units out. They're not necessarily depending on generators at the front lines, but instead they're just as important as water and food is the power for the war fighters these days, and being able to deliver that silent power is part of the game that's played out there. Again, on just the risk of fuel and logistics, there's plenty of stories going all the way back to the Iraqi wars of where logistics was where troops were most exposed. And so being able to bring renewables, being able to deliver a storage option that's very high density compared to lead acid, this is a great way to support that, or just not having a vehicle run. I've worked on a couple of projects where it was an electronic warfare system, and they used something similar to this to turn the Humvee's engine off. And if you've got a big 6-liter motor puttering away, that's a huge thermal signature. So to go cold and go quiet is a part of the game. And having 5 kilowatt hours of storage is more than enough to run electronics for many hours. And then the nice thing is with our equipment, you can actually charge right off of that source within the Humvee. So if the vehicle's moving, you got a 24-volt battery source that's going, you can charge right off of our equipment. And then one of the other risks that we've seen not only in the military, but on the disaster side as well, is oftentimes you'll see 3 laptops being run by a 5, 10, 20 kW generator. So you've got 10,000 watts of capability and you're running 250 watts of load with a couple laptops at a Starlink. And that's a huge waste of fuel. Instead, with this equipment, because we have that very short charge time, you can actually get a unit charged up in 90 minutes or 3 hours, depending on the unit, and get that generator turned off. And now you're using that power exactly where and when you need it. And so it's just a smarter way of using it. And those gallons per hour suddenly goes down. Something that you had to deliver fuel once a day or every other day can suddenly turn into a week because you're using the power in a smarter way. The other nice thing is that, with duty cycle and with storage, these units, they don't really care if they're in a partial state of charge, if you're only able to add 20 or 30 minutes of charging to it and then turn it off. Unlike a traditional lead acid battery, they like to be full and they like to get filled up every time. With these, if you only have a few minutes of charging, that's fine. You can charge and discharge within the state of charge of the battery, and that will not reduce its life over time, unlike a lead acid battery in a traditional sense. We work with a lot of different groups out there. We've deployed with disasters. National Guards used our equipment for disaster relief. The U.S. Forest Service has used our equipment for drone operations. And the FBI has a couple of our units for where they're running some drones. Can't really talk too much about it, but they are running some drones and electronic warfare. Secret Service as well as the FBI are both using equipment for denial of attack or denial of drones. And it doesn't have to always be, some high explosive connected to it. It could be at the Super Bowl where they have to set up electronic warfare in exactly the right spots to cover every avenue. And that doesn't necessarily mean that power is out there. And so
and I will highlight that the use at events of counter drone technology is going to proliferate very rapidly, not just at the Super Bowl. I think you're seeing it at a lot more events. Right now, there's very little deployed in the U.S., even on active bases, and a lot of that's going to be changing in the coming years.
Yeah. Thank you, Paul. And the point of that is that we're not talking about assault drones. We're talking about some Yahoo with their whatever drone trying to fly over, and the risk of airspace, and then the risk of it just falling out of the sky and hitting somebody in the head. There have been injuries in the past with drones causing physical injury to people. So it's not necessarily about terrorists or things like that. It's just about controlling that airspace and owning the airspace so that it's reliable. Been working with the Marine Corps both on drone operations as well as MRO down at Fort Bragg, and Homeland Security along the border as well, using detection. The cartels are just as happy to use observation drones to understand where Border Patrol is. So being able to deploy equipment out that's silent, reliable, doesn't require a fuel source to be able to detect where those drones are, to pick up those EM emissions, and even denial of service with electronic warfare is all part of that story along the border there. And then with the United States
Sorry,
Naval
John.
Academy.
John, I would add, we have military troops deployed. When I was at Carson, home of 4th ID Friday, a good portion of the division's actually deployed right now in New Mexico, Arizona, and Texas without this type of ability.
Yeah, so a lot of idling vehicles, a lot of just sitting around running fuel, and that's really where these products can make a difference. Where we can get those vehicles turned off, lower the number of hours run on those vehicles, and most importantly, reduce their dependency on fuel. We can really increase the endurance of while guys are out there. US Naval Academy talked a little bit about that at the beginning. They are preparing for the future of warfare. So we're working with one of the professors there who's developing shipboarding tactics as well as field tactics with the drones. What I love about this photo in the bottom left corner, if you look to the top left and right, you can actually see two drones hovering, and we were able to provide again for that entire drone ecosystem with the NUE. So we've got our transmitters, the displays, able to charge phones and other convenience items, laptops, and satellite communications, all from that desk and that 3651. Being able to charge up batteries, both for the airsoft guns that they're using for practice. They do use live sims as well. But for just like running around and doing their thing on the weekends, that's a very expensive idea. And so they've adopted using airsoft BBs to simulate those tactics. They even have special drones with an enclosure around them. So they practice crashing drones into each other during those shipboarding activities. So they're not only doing observation, but they're also looking at tactics on how to defend themselves against kamikaze drone attacks and things like that. So it's been a lot of fun working with the cadets, with the midshipmen. And you can even see here, it's a little bit hidden, but this is one of our smallest units, the 605, ready to go for charging and operating the units. For thermal signatures of solar, this is an important part of why, maybe Paul can expand a little bit about what he's spoken with battlefield commanders, but solar panels, they pose some of their own problems with reflecting infrared off of the ground. And so they make for a very obvious target. One of the things that we're working on is a high voltage system so that panels can be deployed a couple hundred yards away from where the unit is, so that if a drone attack comes, the damage is only about 20, 50 meters, depending on the warhead. And so if they're a couple hundred meters away, they would be safe. So there are some tactics and things like that that can be developed around using small wire, like what you for radio wire, and be able to deploy that along with a solar panel, but getting distance, safe distance from it. But just having a unit out there or a solar panel out there, it does pose some of its own risks as it does stand out against the sky. These photos we took over at Camp Roberts over in California. Interestingly enough, it was just something fun to share. We took these photos again at Camp Roberts, as drones have their own thermal signature. And so pointing thermals up at the sky at a drone actually makes it stand out pretty well. This was a 640 by 480 cell or sensor on it with a 2.5x. So what I saw through the viewfinder was close to that photo in the top left-hand corner, but I just zoomed in a little bit so you can see that thermal signatures go both directions. Not only can you buy a $3,000 drone with a pretty nice thermal camera on it, you can point your own thermal cameras up at the sky to see a drone coming in, and they do stand out pretty well. I did find that the winged drones didn't really create much of a thermal signature just because of the airflow, and the electronics are all inside of an enclosure. So you just don't see as much on an exposed drone where the electronic pack and everything else is just right there.
Hey, John, I'd like to comment on the previous slide real quick, on the panels, and just say, the previous, we've encountered various, commanders have
Oh, yes.
commanders have different views on deployment of solar. There are circumstances where there's no other choice. So if you take, for example, island situations, if you're close to in proximity to the enemy, you're not going to you're going to have trouble with fuel anyway for your generator. So they really don't have a lot of other choices. Locating it far away is a benefit. And I would highlight that, so some glass panels and with reflective materials are even worse because so these are actually military grade solar arrays here that are being used. And this is done in the winter in California. So the other, one of the things is you're not seeing a lot of other heat reflection off other items. We're going to run some tests this summer and see how the differentiation is. So, but in our discussions, for example, with people working in Indo-PACOM, there really isn't a substitute for solar, and it is to some extent about clever placement. We are working with some small wind companies in the defense sector, but they just to date are not yet fully ready. But the ultimate combination from us is wind that can run at night and then solar that can deploy during the day. So thanks.
Yes, thank you, Paul. So our drone charging station. So this was asked for not only on the military side, but the film side as well, because we're seeing that requirement for being able to charge and be able to provide for equipment in the field, and having a drone charging station makes a lot of sense. What I love about this unit that you see here, and we'll touch a little bit more, is that it still has AC power. It has internal and external USBs, external AC power. So it's a fantastic case for usage. I do want to spend just a moment talking about how this math all works. One of the confusing parts that can throw people off is this milliamp hours. Milliamp hours doesn't tell you enough about what's going on. It just basically tells you the size of the cell, but it doesn't tell you how many of those cells are together unless you read the fine print. So if we look here on the Turnigy one, we can see that it's a 2200 milliamp hour battery, but there are actually 3 of those cells inside. So it's 11.1 volts. So when we work in solar and we work in renewable energy, we typically put things in kilowatt hours or into watt hours. So when we look at like the 2425, which is our smaller unit, under 70 pounds, that's got a 2.5 kilowatt hour battery, or 2,500 watt hour battery. So at 24.2 watt hours, we can charge one of those batteries 103 times. Now, you saw previously, I didn't do the math on here, that there was a 12,000 milliamp hour battery, and that was a 6S battery. So we'd be able to charge that about 15 times for those really, really large, long distance drones that are made to lift, full warheads and things like that. The other is, of course, DJI has become ubiquitous on the Ukrainian battlefield. And so here we have an example of the Mavic 3 drone. So it's a 5,000 milliamp hour battery at its 4S. So if we take 5 amp hours, which if you just move those dots over 3 to make it a 5 amp hour battery at 14.8 volts. That's 74 watt hours. So we could charge that off our unit 33 times. If you wanted to do the math, if you had a 45-minute runtime and you had 33 charges of battery to go, you would have days of operation use with the Mavic 3. I think you would get worn out along the way. But really, I want to make sure that you understand that this is only part of the story. You also have your controller, you have your goggles, and things like that. The other downside of this is if you said, well, why can't I just bring out a Honda EU 2000 generator or something like that? And that goes back to fuel and logistics. If you're just puttering away trying to charge up one of these batteries over a couple of hours, you've burned a lot more fuel than you needed to, because you would need 20 or 30 batteries to really justify using a 2000 or larger watt generator. So that's where using a small portable unit like ours matched up to these batteries gets the electrons exactly where they need to be without that exceptional loss. Something as simple as just a single panel. This is an example of our partnership with Apollo, that we've got a single panel. Again, if we've got a 2.5 kilowatt hour of storage, that's 2,500 watt hours of stored energy with a 100-watt panel. So on a good sunny day, you can produce about 500 watt hours of storage. We go back to that previous example for battery sizing. You can be able to charge a lot of batteries off of a single panel that easily fits into the back of your car. And of course, we have a lot of different examples of our foldable panels and things like that. So a Starlink somewhere between 70 and 100 watts. So if we just round up to that 100 watts, that's running a Starlink for 5 hours. Typical cell phones, again, are a very small load. And so if you just need that convenience power, being able to run a Starlink cell phone or even a laptop, which is 70 to 100 watts of power, a single panel is going to increase that endurance, get you not only a day, but maybe a day and a half's worth of use out of that system. We're very excited about the products themselves. With our just portable power cases here, we have sort of 3 different examples. That center one is really the size of what our drone charging station is. The product on the right is the 2425, and the product on the left is the 3651. Again, this is our 3rd generation product. We've spent a lot of time talking to our customer base on the disaster side, film side, military side, and developed something that's portable for our larger unit. We're working on an off-road kit, essentially, where we put big wheels onto it, because particularly the film guys were not appreciating dragging it across grassy fields and things like that for that perfect shot at sunset type of thing. And so we're developing products that meet the customer's needs. One of the big differentiators, and it was pointed out in the questions, is that we are a true pure sine wave inverter. I actually have a little cheap unit that I got from at a renewable energy show that somebody gave me because they didn't want to bring it home. And I put it on my scope, and it's a square wave, meaning it goes over, it goes up, and then it comes down. And this is it. And that's all it does. And that is not a good, clean power source. And modern electronics can be quite sensitive to that. Whereas our equipment is truly a pure sine wave. I've looked at it on the scope, and it produces the exact same style of power that you would expect from the grid. And in a lot of ways, it's cleaner power. If you guys live in an industrial area or have worked in an industrial area, big external grid loads can create noise on the grid and cause brownouts, can cause other issues. And then when you start going international, having been to Kenya, Nigeria, South Africa, Cairo was probably some of the worst power. It was consistent power, but when you started looking at it on an analyzer, it was absolutely awful. And so what our equipment can do is we can actually take that dirty power, clean it up, and provide that pure sine wave, so that if you do have sensitive electronics, even radios and things like that, will leverage the AC power coming off of the grid to produce their own sine wave, which is creating the EM fields for communications that can create their own issues with noise on their own signals. And so having clean power is very, very important part of the story as well. Looking at our drone charging station with this example, we have 2 chargers, but we can fit up to 4 inside of there. And each one of those chargers can charge 2 batteries. So we can have a total of up to 8 batteries. What I love about the iteration that we did within this product is that we've got enough room that if you wanted to throw some extra batteries in there, you could. We could easily attach some Velcro across the top to strap in some of your own batteries there. That foam across the lid gives you plenty of space to smush and hold those batteries in place along with the Velcro. We've got internal and external USB. And because the battery is natively 24 volts inside of this unit, they just plug directly from the battery into the charging station. So there's no losses when converting from DC power to AC power, back to DC power through the charger. We can skip the AC side and charge directly from the battery. But if you're running a laptop that you need to have that universal AC power, we can do that as well. And this unit has, again, both internal and external. It is a wheeled case with a carry handle, and the whole unit weighs less than 70 pounds. So it is very one-man portable. A little bit of a pain to get up into a vehicle by yourself, but doable, especially with the handles on each end. It's a 2-man lift. You get into the back of the vehicle, away you go. And you can actually still add solar to this product as well. So it is truly a universal and complete system for drone charging. We have several partnerships plus our own product with solar. Here are the NUE Energy Trifold. We have a 6-panel as well called the Hexfold. This will produce 210 watts, and the Apollo down below will produce 206 watts. Just kind of depends on what your use case is. We have other partnerships where you can get something that folds down to something that's about the size of a medium-sized pizza box. If you had 2 of them stacked on top of each other, and you've got 200 watts there. So it really just depends on the application. If you need something that rolls up and can go onto the pack of a warfighter, there are those types of panels as well. Again, having a 210 watt, that's going to offset charging of a couple of batteries along with a Starlink and a laptop for communications. So this is going to be a mission extender, but most of our equipment, we can add 1,000 to almost 2,000 watts of solar to it. So if you did need a true off-grid system that wasn't dependent upon a generator, that can be designed into this. One other point that I can make on this is that we do have external access points to the battery. So if somebody said, hey, I want a 3651, but I want to add 5,000 watts of solar to that unit, because we have those external ports on there, we can actually add solar with an external charge controller to that unit and build a complete off-grid system, essentially using a 3651 or the 2425. Drones don't just come in the flying space, but they also crawl and swim. We have several drones being used over in Ukraine that are boats, and we have a couple of government agencies that are using underwater vehicle testing with our equipment. The McCarthy example here, it was a drone charging station that we used with our larger unit. So that's a 50-50. So it's a 5,000 watt inverter that can take up to 5,000 watts of solar. And a 5 kilowatt hour battery. But again, because we have external ports on this, we can add another 15 kilowatt hours of batteries. We could have a 20 kilowatt hour system ready to go inside of 2 of those boxes that Zach, one of our employees, is standing next to. What the McCarthy drone did was it rolled out and did thermal imaging of the panels as it drove down to detect if there was any damage to the panels after installation, just as a quality check to the system. So the thing that I love about this job and I love about NUE Energy is with portable power, you really are unlimited with where you want to go. It's your imagination is going to slow you down on what you can do with this product. And we have a full set of teams that can system design and prototype and build custom enclosures and things like that to meet the needs, whatever it is. If it's a 20-foot container with solar on the outside, an inverter, and table space inside, we'd be happy to help and talk about that. Or if you just need a smaller system like this 50-50 you see here, being able to deploy solar, we can easily do that. And again, all of our equipment uses pure sine wave, and we can either add monitoring or we can take it out, just depending on the application and the usage. Paul, any final thoughts for you?
Yeah, well, I just wanted to add that the advent of land drones in the military environment is dramatic. Where companies in Ukraine were building maybe 10 drones a month, they're building over 100 now, land drone wise. A lot of new roles in evacuation for both boats and as well as land missions, and everybody has to come back home and recharge. So we do see that evolving dramatically in the coming years as well. Still behind the air drones, but it's there. So I we have another question. John answered the pure sine wave. Um, but John, can you speak? Mark, thanks for again for a great question. Can you talk to the impact resistance on the various panels,
Yeah, I'll
especially
jump
as
up.
compared to start with maybe glass panels and how vulnerable they are?
Yeah, traditional glass panels, the tempered glass, they do pretty well against typical hail and things like that. But when you get concussive shock waves out on the battlefield, they don't last very long. That tempered glass will disintegrate pretty quick. And one of the reasons that we chose flexible panels, like you see here on the trifold, is because they can take that concussiveness and they can take shrapnel. We've tested with 9mm rounds. As long as you don't hit the critical parts, there's parallel paths within inside the panel. So if one side of the panel gets damaged, you're still going to be able to produce that equipment. Most of the panels that are out there that are flexible do a great job of being resistant to hail and other types of damage as well. But again, if you start getting into those situations where you're going to be on a battlefield, you're going to be in a situation where there are potentials for concussive forces, then you're going to need to choose this style of flexible panel. The other nice thing
Yeah,
is
yeah.
this is
John,
a
if I can comment. So we put 9 rounds of 9mm through each one of these individual panels. And each round knocked down the production by about 8 to 9%, but it didn't knock the whole thing out. And I think that was pretty significant. That's the upper trifold. And so we actually have done our own testing. So any case, I have seen numerous photos of people who wrongly put glass panels within 15 kilometers of a front line and they all shattered. Shrapnel and glass panels don't mix.
glass panels, Paul, just aren't as portable either. And so, it's a very rigid structure, very hard to move around. And we have seen where hospitals were deploying glass solar panels on their roofs and they got taken out by drones. So there's no such thing as you can't attack here or there in warfare. And unfortunately, those panels were destroyed. On the flip side, we do have our trifolds and hexfolds deployed in Ukraine, and they're able to deploy them out when they can and bring them back in quickly if there's an air raid siren or something like that. And so having something that's highly portable that folds down into itself and away you go has extreme advantages. The Apollo is an Israeli company, and they have deployed with the IDF, and they've proven out the same thing with their panels there, is that they're very resistant to physical attack from stones, not so much hail, but stones being thrown at vehicles. But they do deploy their solar panels on some of their vehicles, and the survivability rate has been very, very high with those panels. So choosing the right panels for the right application, reach out to us. We can help you guys decide what the right panel is and help you procure those panels so that you get exactly what you
Yeah,
need.
everything gets matched to the power system.
Yes.
Great question from Melissa. Melissa, about how we work with disabled people. So, not us directly. We enable a group, a disability resource group. They actually purchased one of our Sunwing solar trailers, so that has a lot of onboard capacity and recharging. And then they do what we call the mobile solar generator network. So they purchase a number of the sun cases on the inside of it, and they actually roll this out. And they rolled it out after Helene. And a lot of people, disabled people, actually have to go to emergency rooms after disasters because they run out of power for their medical devices. And in some communities I've come across, very rarely they've taken care of some. Like I was at again, Fort Carson last week. They've outfitted some of their highly vulnerable dependents who have medical devices need to be powered, some with generators, but not everybody. And so wheelchairs need to be recharged. Oxygen concentrators often go with people in wheelchairs. They need they need recharging, and CPAP machines, and there's people who have in-home care. They're quite uh, uh, you know, quite disabled. So the that center then actually can roll out the power units that they have and operate them for several days in some circumstances. If they have a solar panel, they can put that outside the house and just continue because those loads don't tend to be very high, but they can recharge all those devices. And it really is a strain on the medical system when every people show up in the emergency room and all they really need is power.
Yeah.
So I
Yeah,
hope
and
that
to
answers
expand
your
on that a
question.
little bit, Paul, in speaking with the DRC, our portable units, because you can bring it right into the house, bring it right up next to where the person is, their homes are set up for them. And so bringing them to a school gym after a hurricane, not only is it results in a loss of dignity, they don't have necessarily everything that they need, even though the school may have been built to ADA requirements. If you're a quadriplegic, then you have a lot more requirements, and so they do champion independence. And because you can bring out these units into the field, they can swap out and deliver a charged unit to somebody and help them stay in their homes, keep that dignity, and be able to just easily swap that power out. So they have not only the big Sunwing trailer system, but they also have a lot of our portable power units, so they can drop them off, and they've got the list of addresses, they've got a plan. So the DRC does a really good job of planning and making sure that they know the people that are in their community that are going to need that power infrastructure. And they have a plan of being able to swap those units out, or as Paul said, be able to add solar if the loads are small to deploy and create that resiliency and keep the people in their homes, because it is a big resource drain, not only for disaster recovery if you have to bring somebody into a hospital afterwards, but just while they're in the gym waiting for power to come back, that's a big strain on them. So we can run those fridge freezer lights for the customer, the disabled person, as well as the medical equipment they need to stay healthy.
Only final point I want to make is when you do have portable power, you have to be able to store it for periods. We were working with some special operators yesterday, and that was one of their big questions. And one of the things that we do uniquely is in our 2.5 and 5, we do have circuit breakers located inside the unit, so you can disengage the battery and have a very tiny parasitic load. Unlike consumer units that you really have to recharge every 30 days, our recommendation is 6 months. I think that's very important in some of these operating environments. But in general, I don't think there's any more questions. Sorry. I think, let's see. Doug has asked a question about, is there use of military electric vehicles? Well, right now, Doug, they're actually very much being used, but not in the typical form of the mass and size of a Stryker, Bradley, M1, or even a Humvee. They're more irregular, or they're more like the Odysseys or the four-wheel drive type ATVs. You'll see a lot on the internet about Russian use of golf carts, they call them. They're not really golf carts, they're really all-terrain vehicles that are electric. It is very clever because they are stealthy. As special ops guys have been looking at these for years. Um, I think a lot of if we look at conventional military use, no. But if we look at special operators, if we look at irregulars, and if we look at overseas combatants, they're going to be very innovative. And China makes a lot of these. China supports a lot of those guys. We make them. And so there will be growth. There's a lot still being figured out in the military when it comes to electrification. Um, they're not really motivated. They shouldn't be motivated by carbon emissions. They really should be motivated by stealth and the threats that are coming from the drone environment. And we're heading down the road where a couple of years from now, you will not only have you will have the so many drones in the air that you're able to backhaul and you don't have to control them. It'll be all AI driven. So you have so many eyes and sensors out there. And at the same time, you'll have AI swarms be able to come in. So stealth is and movement. I mean, there's certain rules or behaviors in the military that are done if you're in a conflict zone, and one of which is running your Humvee to keep warm or to run your air conditioning. You do that now, and a $4,000 Mavic drone with that's piloting in a $1,200 infrared capable FPV drone. That's what they're running with a warhead on it. So the costs have come down so much that anybody can access this. And the Houthis right now are wreaking havoc with some of our boats because they do understand the drone world, and they do have kids in Yemen who play Call of Duty who can run drones. That's really all it takes is that dexterity. And so it's a changing landscape. And a lot of things, we do, there's an old saying, you do tend to fight the last war. We're probably headed for that, but then we adapt very fast. If you go back 3 years, the first year of the Ukraine conflict was an artillery war. And then we injected dropping grenades off drones, and now it's FPVs. And I was again speaking to some drone teams on a base recently, and they're like, "Oh yeah, I mentioned it earlier. They're practicing dropping grenades down." And I said, "That's so 2023. No people just don't do it. It's evolved so fast that you have the most highly accurate delivery of ordnance. I trained to be able to drop an artillery shell within 50 meters, I hope, of my 10-meter square grid coordinate that I was aiming for. Now you're dropping it, you're running that drone precisely within 1 meter. Okay. And even things like medevacs are going to change because try to shoot an RPG, not very accurate at a helicopter, and you got to be close. But you can be 5 clicks away piloting a drone and running it right through the door of that Black Hawk when you medevac. Ukrainians don't medevac by air, and neither do the Russians. It's all ground medevacs. That's because of the drone war. So there's so much changing. So thanks for that. That was a great question. And oh, John, somebody
I
said,
see it.
yeah, no worries. Anyway, we're going to close it down. Thank you for your patience. We ran overtime, but very, very much appreciate your guys' participation. We're very open to further discussions, and we thank you for the great questions. Have a good day, everybody.
Thank you, guys.